Jai Hind to all. Myself, Shikha Agarwal, Assistant Professor in IT Department of Ajay Kumar Garg Engineering College, Kasip. So, today lecture we are going to talk about the one complex topic of data structure, that is tree traversal. As we know, when I am talking about the tree traversal, there are of three orders: pre-order, in-order, post-order. So, in this lecture we are going to talk about the tree from traversal. Now, before we talk about the methods of traversing, we should be aware about what is tree traversal. We have to talk about the two words, tree and traversal. If I am using about the word tree, it means we have to create an hierarchical structure, right? If I am using the word traversing means whenever we are accessing the each node exactly once, then we are talking about the traversing. So, if I am talking about the tree traversal, we can say traversing is a method in which we traverse, or we can say we visit each node of the binary tree exactly once, right? So, as we know, then how we can visit the nodes? When they are connected with each other. If each and every node is being connected with each other, then only we can visit the node. Fine. Now the question comes, from where we have to start, right? So, generally the tree traversing starts from the root node. As you can see in the diagram also, in this diagram, if I am talking about the root node, then A will be the root node. I can give you an example also. Suppose if I have a tree A, B and C. So, in this tree, as we know that A will be the root node, right, and B will be the left child of that particular root node, and C will be the right child of A. So, we can say when I am doing the traversing, generally we used to start from the root node. Basically, by using the traversing, we can easily search an item into the tree. If I say ki you have to use the traversing method, find H is exist or not. So, what you will do? You will start traversing this tree and you will find an item that whether it exists or not. We can easily count the number of nodes. We can easily print all the elements by the help of traversing. Now, if I am talking about the types of tree traversal, as we know that there are the three types of tree traversal. The first is pre-order traversal, in-order traversal and post-order traversal. What is the difference between in these three orders? We are in this lecture, we are going to talk about how these three traversal methods work. Fine. What is their difference between them, and if the two orders is being given into it, how we have to generate the tree. Fine. So, first of all, we are going to talk about the types of tree traversal, and in this, first of all, we are going to discuss about each and every traversal method. First, we are going to talk about pre-order. If I am using the pre-order, as we know, the pre-order traversal says, first of all, we have to visit root node, then we have to visit the left node, then we have to visit the right node. As you can see into the algorithm also, this is a recursive method which I have written over here, that first of all you have to visit the root node. Fine. Then you have to visit the left subtree in a pre-order, then you have to traverse the right subtree in a pre-order. So, I can explain you by using the simple example. Suppose we have this graph. So, into this tree, what we have to do is, we have to traverse, first of all, traverse from the start node. As in the previous slides, we have studied that we have to start the traversing from the root node. So, pre-order says, first of all, we have to traverse the root node. So, if I talk about the root node, so it means we have to traverse that, we have to study A node. Then after that, it is being dividing the tree into the two subparts. This part is called as a left subtree and this part is called as a right subtree. Fine. Then after that, it says, the next step says that we have to traverse the left subtree in the pre-order. So, left subtree, it means we have to visit this portion of the tree, right? So, if I consider is as a single tree, so again we know that B is a root node. Fine. Again, if it is a B is a root node, again we have to divide the tree into the again left subtree and right subtree. See, fine. and again we have to, steps 2 says we have to traverse the right subtree. In the case of right subtree, again we come to the D. Fine. So we have to traverse D. Fine. After that again it is says ki we have to come into the left or right subtree. So again it is being divided this into the left, and there is no element onto the right side. So we can say we can traverse the left element. After that we have to traverse the right. There is no existence, and again we come to the previous root node. Fine. Again after coming to the previous root node, we have to talk about the E node, because this is the right subtree of that particular element. So this is the way how the pre-order traversing is to be done. I can give you an example. Let's discuss about one example of pre-order traversing. I can randomly write an elements in the tree A, B, C, D, E, F, G, H and I. Fine. So in front of you I have given you a certain example. So first of all we have to talk about the pre-order. In the algorithm we have, remember the 3 steps. First of all we have to visit the root node, then we have to traverse the left subtree, then we have to traverse the right subtree. Fine. So now you can start traversing the pre-order by using this tree. First of all we have to visit the root node. So into that case we will get the root node as A. Fine. Again after that we have to divide the tree into the 2 parts. The first is left subtree and the right subtree. Then as we know in the algorithm we have said we have to traverse the left subtree. If we have to traverse the left subtree, and as I have already told you this is a recursive method, again and again it is being calling until we reach to the final result. So we have to traverse the left subtree. Into this left subtree, this is a complete tree. So you can also write this that this is a single tree. We are not considering as a whole tree. Fine. So this is a one tree. Now again into this tree we are considering that this is a root node. So we can write a root node, and again it is being divided into the 2 parts, a left subtree and a right subtree. So into this right subtree we are traversing the root node. So we will get D. Then after that we have to talk about H, because it is a left child. Then we have to traverse the right subtree, that is I. Then after that we are moving towards the back to the D, B, because why? We have already traversed the right subtree of this particular portion. Then we have to traverse the right subtree, and into the right we are having only a single element, that is E. So we will traverse E. Fine. So now you can see from the bigger tree that we have already traversed the complete left subtree. All the elements are being included into the tree. Fine. So after that what it is being written into the algorithm, now we have to do the right subtree. We have to traverse the right subtree. If I am talking about traversing a right subtree, now you can check the what is the right subtree, C, F and G. Into this particular right subtree we know that C is a root node. So first of all we have to traverse the root node, that is C. Then we have to divide the tree into the left and the right subtree, right? So we know the left is only F, so we will write F, and in the last we know the last element is G, so we are traversing into the G. Fine. So this is the way how you are traversing the pre-order. Now let's talk about the in-order recursive method. In-order means the root node is to be in between. As I am giving you an example of expressions also, what we are writing it is as, if I am writing this way A plus B, so it means between the between the 2 operands there is always an operator, right? So into that case we are having an operators. This is what we have studied, right? So similarly in the case of in order also, first of all we have to traverse the complete left subtree. Fine. This is the algorithm which is being shows a difference between in order, pre-order and post order. So first of all we have to traverse the left subtree, then we have to visit the root node, then we have to visit we have to traverse the right subtree in an in order tree. Fine. Now you can check the example also. Into this example, you know, I have already told you whenever we are doing traversing, we have to start the traversing from the root node. So first of all, if I am talking about the traversing from the root node, right, so we have to divide the tree into the 2 parts, because it says first of all we have to traverse the left subtree. So again it is being divided in the 2 parts, right? This is left, this is right subtree. Fine. After that, if I am talking about the left subtree, we are having a B, we have a D, we have H, then we have E. This is a left subtree. Now you have to start tree traversing in order. Fine. In this case, now if I am talking about B, again it is a root node, so it is again dividing the tree into the two parts. First of all, we have to traverse the left subtree. Again in the case, we are getting only the tree as D and H. Fine. So this is a single tree which we are getting it. So after that, we are talking about this tree. So in this case, we have to traverse the left subtree. What is the left subtree? That is an H. So into that case, the first element will be H. Fine. Then we have to visit the root node. What is the root node? That is a D. Who is the root node of H? That is D. Then after that, who is the right child of that tree? No one. So we will not write it. Then after traversing it, now comes to the back to this tree. After coming into this, we know from the D, we have to move back to its own root node because we have already traversed the left subtree. After that, we will get the root node as B. Then after that, we will get the E because of right child. Fine. Now you can check from the A root node, we have already accessed each and every element of the left subtree. Fine. Then after that, we have to visit the root node. The root node is A. Then after that, we have to traverse the right portion. Fine. So this is the way how you have to do the traversing of a in order. Now I can show you one example again in the similar manner. If I say, if I am writing the A, B, C, D, E, F, G, H and I into the given tree. Now let's see the example of in order. We know the recursive method says we have to first of all visit the left subtree of the in order. Fine. Then in this case, we are dividing the tree into the two parts. This is the left subtree, right, and this is the right subtree. Fine. Then in this case, what we have to do, first of all, we have to traverse the left subtree, then we have to write the visit the root node, then we have to traverse the right subtree. If I am talking about traversing the left subtree, it means I am talking about this tree. So we are here, again we have to divide the tree into the two parts. So again we have to visit this node. Now after that, it is not being divided into the tree, this is a left, this is a right. So the first visiting left node is H. Fine. We have already visited the left sub trees and so part of that tree. So then after that, we have to move to the visit of the root node, that is D. Then we have to traverse the right subtree of the tree. So that is only I. Is it clear to all? Then after that, again from the D, we have to move to the root node, that is B. So in the case of B, you can check that we have already traversed the left portion of that particular tree. Then we can say it is B. Then after that, we have to traverse the right side, that is E. Again after B, we have to move to the main root node again, right. When we comes to the A, you can check we have already traversed the complete left subtree, right. So again we have to visit the root node, that is A. Then after that, we have to visit on to the right subtree. Again in the case of right subtree, there is a small tree. Fine. In the case of this tree, this is a root node. So first of all, we have to traverse the left subtree of that node. So we have to write F, then we have to traverse the root node, that is C, and finally we have to traverse the right node or right child of that particular tree, that is G. This is the way how you have to write the in order traversal. Fine. Now the last method is post order traversing. As we know, what is the meaning of post? Means visit the root node in the last. First of all, we have to traverse the left subtree, then we have to completely traverse the right subtree in the post order, and then finally in the end we have to visit the root node. Fine. So in this case, again as we have already told you that first of all we have to visit the root node, we have to traverse the root node. So again into the given tree, we have to divide the tree into the two parts. From the root node, that is a left subtree and right subtree, right. See, we have divided the tree into the right subtree. What is the algorithm says? That first of all, in the case of post order, we have to traverse the complete left subtree. What is the left subtree? This tree is called as a left subtree. Now doing the traversing, again we have to follow the same method. Again the left of that, so it means we have to write H. In the case of this small tree, there is no right node, so we'll not able to write it. So again we have to visit the root node D. Then in this case, if I am talking about this whole tree, we know that E is the right subtree of B. We have already traversed the left subtree, fine. So traverse the right subtree, we are getting an E. Then finally we have to visit the root node, that is B, fine. Now when we come to the again from A and I, when we come to the A, but algorithm says now we have to traverse the right subtree. Right subtree means we cannot visit the root node now. First of all, we have to visit the right subtree. In the case of right subtree, we have this small tree, right? So into this case, first of all, we have to visit the left node, that is F. Then we have to visit the right side. Now you can check one condition, that into this tree, it is not having a left child. Once it is not having a left child, so we are not able to write the left child. So first of all, we have to write the right child. Then we have to write the visit the root node. Then after that we have to write the, what we have to write? We have to write the visit through the root node. And finally when we traverse completely the left subtree and the right subtree, we have to finally comes to the root node, that is A. Now you can check the difference in all the three orders. Root node is A, fine. In the case of Postorder, it is coming in the end. In the case of Inorder, it is coming somewhere in the middle, fine. And in the case of Preorder, it is coming in the initial. As the algorithm says, in the case of Preorder, root node is the first node. In the case of Inorder, it is giving that it is somewhere coming in the middle after traversing the left subtree. But in the case of Postorder, it says that it is being coming in the end, right? So you can check all the conditions of Inorder, Preorder and Postorder. I hope you all understand how the Postorder Inorder traversing is to be done. We can check one more example of Postorder. A, B, C, D, E, F, G, H, I, fine. Now Postorder says, first of all we have to traverse the left subtree. So this is our left subtree, this is the right subtree. In this case, now you can check. First of all, if I am doing the traversing, the first element is to be H now, the right tree is to be I, then we have a D, then after that we have to traverse the right portion, then it is E, then we have B. Then after that, if I am talking about the right subtree, then we have, first of all we have F, then we have G, and finally we have A. Now in the similar examples, you can check the location of the root node is being changing, right, as per the given algorithms. Now in this lecture, we are also going to discuss about when the two orders are being given to you, how you have to generate the tree, right. Please remember one thing, that when I am talking about Preorder, Inorder or Postorders, what is their methods, how the traversing algorithm works. Until and unless you are not aware about the algorithm, you cannot work, right. Now if I am talking about the first case, the first case says when we know the Preorder and Inorder of a given tree, right. As you can see that this is the Preorder is being given and here the Inorder is being given, right. First of all, what we have to do, we have to start traversing from the Preorder, and once we start the Preorder, we know that we have to start traversing from left to right. Why? Because we know that first element will be the root node in the case of Preorder, fine. So if I say A is the first element to traverse, we know it is a root node. So what we have to do, we have to do about the A. Now in the case of Inorder, we have to check the location of A. It is in the middle, right. So you can see these number of elements are on its left side of the tree and these elements are on the right side. So after that A, you have to check how many elements are on the left, 1, 2, 3 and 4, and simultaneously after A, all the 4 elements will come into the left subtree. So what you have to write, again you have to divide the question into Preorder. Now what is the next 4 elements, that is B, D, E and F. What is the Inorder? D, B, F, fine. And again the rest of the tree is being divided from that part, that is preorder C, G, H, J, L, K, and similarly rest of the in order we can write, that is G, C, L, J, H, K. Now in both the cases you can check that number of elements in the pre-order and in order are similar. The above question is being divided into the two sub parts. Now you can check all the elements are similar but they are on the different locations, fine. Now you know, first of all we'll solve the left portion of the tree. We know that B again is a root node in the case of pre-order. So if it is a root node then it is located into this, so we can say B will be the root node and it is being divided the tree into the two sub parts. D will be alone, so it will always become the left child, right? Because B से पहले क्या है, all the elements is only single element is there, so we can say it is only D, fine. Again you have to divide the question into pre, that is E, F, and in the case of in order it is written as F, E, fine. Now again we know in the case of pre-order E will be the root node, fine. If E will be the root node, so it will become E. Now we have to check whether F is on left or right, right? So that we will check from the in order. In the case of in order it says F will be on its left side. So what happened? This will becomes F, fine. In the case of this, if I generate the trees here, A, B, this is D, this is E, and this is F. Now you can see that we have already completed the left portion of the tree. Now let's talk about this side. The first element is C. Now in the case of in order we can check C is a root node and after that only G is on the left side. So we can say here the C will come, G will be the single node and simultaneously it will generate the pre-order that H, J, L, K in order as L, J, H, K again, fine. Now you, in this case again G is a single element, so you will not need to check. Again we have to check in the case of pre-order H. Now you can see H will be the root node. So in the case of in order, now here H will come, K is a single element, so it will go into this side and again it will generate the pre-order and in order, that is L, K, sorry, J, L and L, J, fine. Again we have to check I in this is an element, that is J. So J we can check that J is a root node. In the case of this J will become here and L will be the left child. Why? Because in the case of in order it is coming into the left side. Now you can see the tree also. In spite of that, now the C having a single element, that is G, then after that C will have a right child, that is H will have a left child, that is J, and J will have a left child, that is L, and finally H is having a right child, that is K. So now you can check the tree. This is the way how you have to generate the in order and pre-order tree. Is it clear to all? Now we'll discuss about the second case. The second case says, we in the two cases is being given. Case 2 says when the next two orders is being given. The first is post order and in order. We know that in the case of post order, we are aware about that last node will be the root node. Because in the case of post order, first of all we have to traverse the root node, first of all we have to traverse the left subtree, then right subtree, and finally we have to traverse the root node, right? So in the given post order, we know that this is the root node, right? So what we have to do, we have to start traversing from left to right, right to left, fine. So now after that, what we have to do, how we have to create the tree? First of all, we will traverse from right to left in the case of post order. The first element is A. if the first element is A, in the case of in order, we have to check where it exists. It is existing somewhere in the middle. So we can say in this case these elements are the part of left subtree and these elements are the part of right subtree. Fine. So how you have to draw the tree? That this is the root node, fine, and D, B, F, E, these are the right child, left child, and G, C, L, J, H and K, these are the right child, fine. Now what is the next element? That is C. If the next element is C, now what you have to do, you can check C is here, so you can do the middle split, then you can say this is the root node C. Now the left element is G. The next is L, J, H and K is the right child, fine. Then after that you have to visit H. In the case of H, we know this is the middle element, we can say this is H, this will becomes L and J and this element will be K, fine. Then after the H, next element is K. The next element is K. As we can see in the diagram that K is a single element, so we need not to split that element. We have already visited the node. Then we have to talk about J. Now you can check about the J. Again the middle split, this is the J and now you can see this is a left child, fine. Then after that we are talking about L. L we have already visited because it is a single node. Then we are talking about the G. Then G, again it is a single node, we have already visited. Then we are talking about B. In the case of this B, here the B will come, this is D, this is F comma E, fine. Then after that we have to visit E. In the case of E, again a middle split, this will comes as E and you can check F is on the left child, so it will become the F. Now the final tree will becomes as A, B, C, G, H, K, J, L, D, E and F. Now by using both the methods, you can check in the previous example also I can show you that both the trees are similar. See, this tree I have already generated and simultaneously by using the same way in the case of post order we are getting the same tree, right? Sorry, this is L, right? So we are getting the similar tree, fine. So we now by this example we can prove that in any of the methods we are giving any order, but simultaneously after using the recursive algorithms we can easily or traverse the tree whenever it is being required, fine. Thank you.